If I were to give you this function f of x equals 3 to the power of x, how would you go about finding the inverse function? So for example, if I put a negative 2 into this machine, well, 3 to the power of negative 2, that would be 1 over 9. It would spit out the number a ninth. And then if I put in 0 into the machine, 3 to the power of 0 equals 1. It will spit out this number 1. And then if I put 3 into the machine, it will spit out 27. How would you go about finding the set of instructions that will undo everything? So for example, if I put a ninth into the machine, it will do something, the machine will do something, and then it will reverse the whole thing and spit out the number negative 2. So if I put in a negative, if I put in a 1, it will do whatever it has to do. It will spit out the number 0. And then if I put in a 27, it will do whatever it has to do to spit out the number 3. Or what is a set of instructions that will undo everything? So for example, we've done this in the past. If I were to give you this function here, if you put in a negative 2, negative 2 times 2, that would be negative 4. Add 1, it will spit out the number 3. If I put in a 0, it will spit out the number 1. So what's happening in this machine is you times by 2 and then you add 1. So the inverse function would be you taking away 1 and then dividing it by 2. It's you undoing everything. But when we try and find the inverse of this, what we did, our technique was this, and there are many ways of doing it, one of which was this. Let's just imagine it as this. Make x a subject. So take away 1 from both sides, and then divide it by 2. So that would be this. Take away 1, and then divide it by 2 equals x. And then we would replace this, this y with an x. So the inverse function is written as this. So this is what goes into the machine. So it would be x minus 1 over 2. This was a technique we would use to work out the inverse function, because you can see when you put in an x, you take away 1, which is what we've done here. We take away 1 and then we divide it by 2. We then divide it by 2. But then how would you go about doing it for this function? So in short, find the inverse function of this. So find the inverse function. Give it a go. Press pause and have a go. Okay, so to do this, let's just say y equals 3 to the power of x. So now it's just a matter of making x a subject. So to make x a subject, what we're going to do is we are going to log base 3 equally to both sides. So that would be log base 3 of y equals x. So there, we've just made x a subject. So now to create our inverse machine, we would replace this y with an x. So that would be equals log base 3 of x. So our inverse function is actually log base 3 of x. So let's test it. Hang on. Let's just test this. So if we put in the number 1 into this machine, it would be this. It would be log base 3 of, well, when we put 1 into here, it would be 1 in here. So that would be 1. So what does this block mean? Well, our eyes would zoom into the 3 and we got to translate this block. What does this block mean? Well, we got to zoom into the 3. 3 to the power of what will give me this thing here. And then the whole log block itself is talking about the power only, the index only. It turns out to be 3 to the power of 0 equals 1. So you can see that when you put 1 into the machine, it will spit out a 0. All right, let's test it with the other two. So now let's put 27 into the machine. So log base 3. So when you put 27 into here, it would be log base 3 of 27. So log base 3 of 27. So now we've got to translate this block. We don't know what it means. So your eyes should zoom into this base and translate it. 3 to the power of what will give me this thing here. So the whole log block itself is talking about the index. It turns out to be 3 to the power of 3 would give me 27. So the whole log block itself is 3. So you can see that when you put 27 into the machine, it will spit out 3, which is really undoing what you've done up here. Now let's put a 9th in there. So hang on, let's put a 9th in there. So when you put a 9th into here, it means that you put a 9th into here. So that would be log base 3 of 1 over 9. So now we don't understand what this whole block means, so let's translate it. Your eyes should zoom into this 3 to the power what will give me this thing here, will give me 1 over 9. It turns out to be -2, because when you look at this, 3, we don't understand what it means to have a power of a -2, so we would jump to 1 over 3 to the power of the positive version, which is this thing here. Well, the point here is that when you put a 9th in here, it will spit out a -2. So the inverse function is really log base 3 of x. So when you're trying to find the inverse function of this, it's actually log base 3 of x. So hang on. So 3 to the power of x looks like this. 3 to the power of x looks like this. When x is 0, this thing here would be 1. Well, we don't understand what this log graph is doing, but we do know that this log thing is the inverse of this. Remember, when something's an inverse of the other thing, it's really a reflection along the diagonal line. It's a reflection along y equals x. It's a reflection of it. So when one thing's the inverse of the other, it's just a reflection along the diagonal line. So when someone asks you to sketch, when someone asks you to sketch this graph, log base 3 of x, you don't know what this graph looks like, but in your mind, picture 3 to the power of x, picture y equals 3 to the power of x. Well, this thing here is the inverse of this, so it's going to be a reflection along the diagonal line, so it will look something like this. And when someone asks you to sketch y equals, I don't know, let's say log base 7 of x, just picture this in your mind. Y equals 7 to the power of x. Remember, it still goes through 1. We don't understand what this graph is doing, but we do know that this is a reflection of this along the diagonal line. So picture the diagonal line and then just reflect it. It will look like this. So this is log base 7 of x. So picture 7 to the power of x in your mind and then reflect it. So this is your log base 7 graph. Okay.